How's it going, you pre-calc kids? Today we are looking at 5.1. We'll call it 5.1a. We're going to look at the well, I call them fundamental identities. You guys are going to probably call them the mental identities. But pretty much we're going to learn how to take trig functions, change them from one identity to another, depending on what we're given. In fact, if you look over here, we're going to learn about identities. You're going to find out who you are, who I am. By the way, I equals Mr. Twilliger. You're going to learn your basic trig identities, Pythagorean identities, co-function identities, odd even identities, and you're going to learn how to simplify and solve some trig functions given complex functions on top of functions on top of functions. Okay? Alright, let's get started. First one we're going to look at is called your reciprocal identities. What this means is, by the way guys, I hope you guys know these by now. Cosecant 1 over sine, secant 1 over cosine, cotangents 1 over tan. That wonderful piano playing was my daughter. Tan is 1 over cotan, cosine secant 1 over secant, sine is 1 over cosecant, because these are reciprocals, guys. We learned that. These two are going to be noteworthy, and that's just because they're so important and come up so often. Tan of theta is sine of theta over cosine of theta. Cotangent, your crazy silly book, is actually cosine of theta over sine of theta. All these things are equivalent statements, and they work all the time, except when they aren't defined. Remember that little unit circle? Here's some things you gotta keep in mind. Right? Remember your x is equal to your cosine, your y is equal to your sine. So where's cosine 0? Well, it equals 0 at pi over 2 and 3 pi over 2. Where's sine 0? Well, that's going to be at 0 and pi. Okay, keep this in mind. Because guess what? I can't take secant then of pi over 2 or 3 pi over 2 because, well, it doesn't exist. Can't divide by 0. Okay, it's the same as like your tangent. And you have to check your denominators, guys. You have to. Okay. Pythagorean identities. Okay. Go back to what we were talking about before. Remember how cosine's your x, this is your y, and that's actually a coordinate. Those are points. And they make a triangle, like if this was our unit circle. Right? Well, if that's my unit circle, and that's a right triangle, x squared plus y squared equals 1. By the way, these are definitely noteworthy, guys. Cosine squared plus sine squared equals 1. E.g., for example, your cosine of pi over 2 squared. By the way, this squared up here, that means this whole thing squared. Plus sine squared of pi over 2 is 1. And you can plug that in a calculator and check it. I'm just going to put this so you guys know what we're talking about. Craziness. The craziness. Okay, the next one is 1 plus tan squared of theta equals secant squared of theta. Okay? Now these thetas have to match. So corollary to this would be that your tan squared of theta equals secant squared of theta minus 1. That's going to be really important to know when you guys get into calc, actually. When you start doing integration, this stuff comes up a lot. And your cotangent squared plus 1 equals cosecant squared. Also, corollary to this one is cotangent squared equals cosecant squared theta minus 1. Okay? Whew! Now, let's actually do one of these. Okay? Find your sine and cosine if your tan of theta equals 3. Okay, we can do that. Here's how you set it up. So your tan of theta equals 3. Now we have to ask ourselves, how can I get from tan to another one of the functions? Let's take a look back. Well, here's a tan, right? 1 plus tan squared of theta equals secant squared of theta, right? Oops, wrong button. Okay. So I know 1 plus tan squared of theta equals secant squared. Right? By the way, guys, definitely noteworthy here. Now, what do I know about tan? I'm going to do this in blue so you can see this crazy substitution. So I know 1 plus 3 squared equals secant squared. I did that because tan's equal to 3, or tan of theta is equal to 3. So I plug in 3 for tan of theta. So I get 1 plus 9 equals secant squared of theta. I can't forget that theta in there. Okay. So I get 10 equals secant of theta. Secant squared. How do you get rid of squared? Square root both sides. So square root of 10 equals secant of theta. That doesn't give me anything yet, does it? No. What do I know about secant? Secant's 1 over cosine, right? So, secant's 1 over cosine. I can say square root of 10 equals 1 over cosine, right? Which means I can say 1 over square root of 10 equals cosine of theta. I can flip them both around. Okay, don't tell your teachers this, but I'm going to leave this one here like that. Now, it says cosine is less than 0, right? So here's what you do. A 1, a 2, a 3, you put a negative sign in front. Easy? Easy. Sorry. So that's my cosine, right? Phew! Now I'm going to have to find my sine. Oh boy, oh boy, oh boy. 2 ways to do that, guys. Way number 1 is, I guess so, we have to find sine. Okay. Well, tan of theta equals good old sine of theta over cosine of theta, right? How do I know that? Pow! Right there, as John Mann would say. So, I also know this equals 3. Right? Well, it's given to us right here, circled in blue. Now, cosine is equal to negative 1 over square root of 10. So I can plug that in down here. Right? Well, of course I can, silly gooses. Now, I'm going to multiply both sides by 1 over negative root 10. And I get sine of theta equals negative 3 over square root 10. Pretty easy, right? Right? I understand. Okay. You know what? This cofunction identity. What I basically want you to see is if you have two angles on a right triangle, you don't have to write it, and they complement each other, right? They're at the right angle of their next two. Your sine of the one angle is equal to your cosine of the other. See that? And your cosine of the angle is equal to the sine of the other. Okay. Your tans are reciprocals. Just pay attention to that sort of stuff. Hey guys, I'm going to go rogue for a second, make up a few more problems that you might see. I'm going to probably give you guys a worksheet over this one. Okay, so let's say I ask you to simplify something like this, cosine theta times cosecant of theta. And whenever you see simplify to one function, a single trig function. Okay. So what you do is you substitute what you know. Well, cosine, you don't really have a substitute for it. But what can you substitute in for cosecant? Well, 1 over sine of theta, right? You multiply those out, what you get is cosine of theta over sine of theta, right? What's cosine over sine? What's cotangent? Okay, how do I know all this? Because I look at those things from before and I learn them. Okay, another one you might see is something like, what's 1 minus sine squared of theta? Simplify it. Well, what's 1 equal to? Well, it's equal to cosine squared of theta plus sine squared of theta. Right? From right here. Cosine squared plus sine squared equals 1. Now I subtract from that my sine squared of theta. These cancel. And I'm left with just cosine squared of theta. Okay. Now I'm going to do one more example. It's kind of tough. Okay. In fact, I'm going to steal it from another worksheet. Okay. Last one, guys. Let's say I had 1 minus sine of theta times 1 plus sine of theta. And a lot of people say, I don't know what to do, I'm so confused. You guys remember this thing? If you have a minus b times a plus b, do you remember what that equals? It's a special identity. That's a squared minus b squared. Okay? In this case, my 1 would be my a, my sine would be my b. Okay, that's back good old algebra in algebra 2, right? So I go 1 squared minus sine of theta squared, which is 1 minus sine squared of theta, which, what's 1 equal to, guys? Cosine squared of theta plus sine squared of theta. And I subtract from that my sine squared of theta. Ba boom, bada bing. Cosine squared of theta. That's where we'll end it, guys. Enjoy.